Gentlemen, Assalamu alaikum. This is the fourth lecture of this course, and today we have to start the very important topics, that is the systems of protections, or you say the classification of protection system. The all the protection systems are divided into these groups, as you see in the slides. Number one is overcurrent protection. Number two is distance protection. Number three is differential protection, and number four is pilot protection. Pilot protection is further subdivided into pilot wire protection, current protection. There are some two more, of this pilot protection, that is the fiber optic protection and microwave protection, which is not included in your this course. So today we will have to take the overcurrent protection first, and then we will go to the distance protection, differential protection, and of course the pilot protection. So first, the overcurrent protection or the overcurrent relays. This is the topic we have to cover. Now, overcurrent protection has the following types of relays. Uh, you may say the first generation of these relay is electromagnetic attraction type relay, and of course the electromagnetic induction type of relays. And then of course you may say the second generation of these is the electronics relay, and you may say the third generation of these is the microprocessor based relay. So the use of electromagnetic attraction type or electromagnetic induction type is not totally abundant. It is still being used in many locations. So we have to start from this basics, that is electromagnetic attraction type of relays. Okay. Now you see the first is electromagnetic attraction type of relay. But before starting the construction or the derivation of these type of relay, first I have to just have to consider few points or discuss few points with you. Now, gentlemen, one is overcurrent relay and the other is directional relay. The directional relay is also called reverse power relay. Reverse power relay and directional relay is one and the same thing. Now, on the power system, there are some locations where power can flow only in one direction. There is no source on the other direction. So, in case of any fault or in case of any short circuit, the power cannot reverse its direction. The power is flowing only in one direction. Therefore, at these locations, only a simple overcurrent protection is enough. There is no need of any directional relay. The directional relay operates only in one direction, or the reverse power relay say is working only in one direction. It operates only when the power flow in a particular direction, that is away from bus bar. Gentlemen, it has a wattmetric type of characteristic. As the wattmeter is reading in the forward direction, when the current and the voltage are in the same direction, then the wattmeter gives you certain reading. Otherwise, if the voltage is reversed, the wattmeter will not give you a reading. It will click backward. Therefore, for the directional relay to operate, you just note this point clearly, and then you note this point, and then I have interaction with you about these type of. So you just raise your points, your questions, or any queries you have in this particular, because these are new things for you. You must have to take care of this. You know each and every point. Okay. So I'm just narrating these at location where power can flow in both directions. All overcurrent relays must be supplemented by directional relay. Either overcurrent directional relay is used. Overcurrent directional relay is there is one relay in which both these properties are there. Attributed both these properties, that is overcurrent and directional. Either a separate direct relay may be used whose contacts are in series with the contacts of overcurrent relay. If there is overcurrent, number 1 point, and if the power flow in a particular direction, that both the contacts will be closed, and then of course your trip circuit will be completed. Otherwise, if only overcurrent if only overcurrent contact is closed and the directional contacts are open, the circuit will not be completed or is not completed, and of course there will be no interruption in the current. Okay. The directional relay operates only when the power current flow only in the forward direction. If the power current flow in the opposite direction, the relay does not respond or operate. Okay. So you must understand this point very clearly, that all overcurrent relay must be supplemented with the directional relays, if the power there is possibility that the power can flow in both the direction. Okay. Now you see this figure. We have an electromagnet, uh, and basically you see, this electromagnetic may be energized from an AC quantity or from an DC quantity, but more or less it can be used for a DC circuits. So more or less we have this electromagnet, and we have this of course plunger type of structure below this, and if the attractive force of this electromagnetic increases beyond a certain limit, which occur when fault occur, when the current increases, then of course it attracts it towards itself. And you see at the right side of this we have a trip circuit, and a short circuit these, and this goes direct to the trip circuit, and the trip circuit is completed. So this is the basic structure. It can be even armature type, it can be any other type uh, of structure. Not necessary that this plunger type of structure is there. It may be. This is sorry. This is armature type. Oh, I'm very sorry. I'm very sorry for this. This is not armature type. This is plunger type. That is. So if it may be plunger type or attractive armature type, so from either single current AC or DC or single voltage AC or DC, from that. I think I have to record this once again to understand this point. Hmm? No, no particular sir दादा this structure मैं attraction type plunger type के लिए हाँ हाँ So this is basically this figure is for of course armature type. This is not for plunger type. It may be plunger type. It may be plunger type. So this electromagnetic actually attract this structure below, and if the electromagnetic force, which is direct, because the turns are fixed, so the attractive force will only depend upon, of course, the current, directly proportional to the current, and the current increases during, of course, the short circuit. Therefore, the attractive force of this increases, and attract this structure to itself. And on the right side, there this you see just a trip circuit, and this trip circuit is completed, and of course, we have the opening of the circuit breaker is initiated. CBC, it is been written, it may be a plunger type or attracted armature type actuated either from a single current AC or DC, so or a single voltage AC or DC. Okay. Now operating principle. Operating principle, you see here, the electromagnetic force developed on moving element is proportional to square of flux in the air gap, and square is directly proportional to the magnitude of the current. If saturation is neglected, if saturation is neglected, right? You see what is saturation? When saturation occurs in any system, the increase of current cannot increase the flux. The flux is directly proportional to the current below saturation point. If saturation occur, if saturation occur, right, there will be no increase in the flux. I already given you some example in the previous lecture that when you have any glass, it has a certain capacity of liquid to hold. If you increase the quantity of liquid beyond that particular point, there will be no increase in the volume of water contained by that particular glass or any other vessel. So therefore, any magnetic circuit, I am talking about magnetic circuit, has a certain capacity to hold the charge. If the flux increases, or certain capacity to hold the flux, let's say, not let's say the flux. If the flux increases beyond a certain limit, it cannot be retained by that particular circuit. So how the flux is increased? The flux is increased by the current. So you increase the current to any value. If the saturation occurs, there will be no increase. There will be no increase in the flux. So this equation which you see, force is directly proportional to the square of the current, because force is always proportional to the square of the flux, and since flux is proportional to the current, therefore flux is proportional to the square of the current, and therefore if that is the force of attraction is equal to K1. K1 is a constant of converting this current into force, and I square, I is the magnitude of the current, minus K2. K2 is of course below it is written force, net force, K1 constant, conversion constant, and K2 restraining force including friction in the system, because anything with move has certain inertia and there are certain friction in the system. So all these combined together, these form restraining forces. So for the relay to operate, the actuating force of the or the operating force must be greater than the restraining forces. Then of course the relay will operate, or the force of attraction will be greater than the restraining force. And I, the current in the relay coil. Now, gentlemen, you see here when the relay is on verge of operation. Verge of operation is that point where the operating force is equal to the restraining force and the net force F is equal to 0. So if you put F is equal to 0 in this above equation, we get this following equation, because if you shift K to the other side, then K1 I square is equal to K2, and I is equal to K2 divided by K1. And this is of course the preset value of the relay. When this magnitude of the current is reached, the relay is of course is operated, right? So we have already defined these quantity in the first lecture, or maybe in the second lecture. Not remember the that is the all these definition for the protection system. Operating current, you may call it operating current, preset current, or operating current of the relay. So this is of course the operating current of the relay. Okay. Now, gentlemen, the construction of this relay is of course very simple construction, but is very slow type of relay. Advantages of this relay is this relay can be used for both AC and DC quantity, because the torque is directly proportional to I square. It has lightweight, light moving parts, small length of travel of armature or plunger in the air gap, therefore relay. And some operation these are fast, but when you compare with the fastest relay, this comes to be not so fast. as we have to consider next type of relay. Now see here, it has no directional control. As I have discussed at the start of this lecture, that directional control means, in this particular case, directional control means that if the current flow in any direction, either in the forward direction or in the reverse direction, the relay has to operate. So if you want to use this relay at any location where power can flow in both the direction, then of course it must be supplemented by a separate directional relay. In its own characteristic, it has no directional control. With the current flow in the forward direction or the current flow in the reverse direction, it may be, of course, no relay. The relay may be made directional relay by following arrangement, which I have told you that a separate directional relay may be used in series with this, along with this, so that it may have directional term if it is needed. And if it is not needed, then of course it's okay. Now, gentlemen, below this, uh, we have a graph. On the x-axis we have torque, and on the y-axis we have two quantity, voltage and current. By these two quantity, voltage and current, it means that this relay may be operated from a current source or a voltage source, both. Either it is to be fed from a voltage source or it is to be fed from a current source. This relay has to operate. So there is a boundary line. There is a boundary line. Uh, there is a boundary line, and we have seen in the previous say slide, we have seen that for the relay to operate, I should be equal to K2 divided by K1 under root, where K2 is the restraining forces and K1 is the force conversion constant for the current to be converted into a force of attraction or repulsion. Uh, okay, so there is a boundary. At this boundary, if the current or voltage increase beyond K2 divided by K1 under root, we enter into a positive torque region. Positive torque region is that region in which the relay operates. Below this, if the current or voltage is less than K2 divided by K1 under root, then we have a negative torque region, and negative torque region is that region where the relay does not operate or cannot operate. Right? So you must have understand this graph. This clearly shows the boundary of the positive torque and negative torque, and positive torque is defined as that torque area where the relay operates, and negative torque region is that area of the graph where the relay does not operate. And both these depend upon the magnitude of voltage and current, and it is very much clear and visible from this particular graph before your review. There are some more structure. The previous structure from which we have started was, of course, armature type, and of course this is, of course, plunger type. This upper one is, of course, plunger type. Uh, you see here, and this plunger go in this particular, of course, coil inside, and we have a trip circuit, and below this we have another structure like this, which is very simple structures, and it is also, you see, armature type of structure. The below one is, of course, armature type of structure, if you see it. Okay, now gentlemen, as we define that at some location we required a directional relay to overcurrent directional relay to be used. So how to make this simple attractive type relay to be in the directional relay and its own structure and its own characteristic? It is non-directional relay. So now this is how I show you how this relay can be made a directional relay of electromagnetic. That is the same electromagnetic attraction type of relay. There is no induction type of property here. We just discussed this, the figure before you. Direction relay of electromagnetic attraction time. Now, if you see this, we have two magnets. One magnet is called a polarized magnet. You see, we have structures normally, and it is fed from a coil where a particular direction of current is given, IP direction. You just see IP direction. So the upper pole of this, which is shown in two parts, is because current enter at this particular pole, so that become north pole, and the below one will become a south pole. Even if you are not using this electromagnetic, you can use even a permanent magnet of this type, where one pole will be negative, one pole will be north, and the other pole will be, of course, south. So instead of this is electromagnet. If you are not using electromagnet, you can use even permanent magnet, where one pole is, of course, north pole and the other pole will be south pole. Now these are permanent poles until and unless the polarized supply polarity is changed. But this polarity remains fixed. So the upper pole is, of course, north pole, and the lower pole is, of course, south pole. You understand this one? Okay. Now, in between these poles, we have an armature structure. Right? And this armature structure is wound with a coil, which is written on this actuating coil. And you know what is actuating quantity? It is being defined previously. Actuating quantity is that quantity which actually needed for the operation of the relay. It may be in the current shape or even in voltage shape. So you must have operating quantity or actuating quantity, one and the same thing. So this coil is actuating coil because actuating current or operating current is flowing in this particular, and this is another electromagnet. Okay. So on the right hand side where the windings start, and you see the direction of IA is upward, this is, of course, becomes north pole, and the other pole becomes the south pole, and we have this arrangement. This is being in the left hand side. It has a contact with the upper this, and it has a control spring, so that this control spring provides some restraining force. Because if this control spring is not to be used, then of course the movement of this will not be, of course, like it will operate with any quantity. It will just have to vibrate freely. So to avoid this, we must have to provide some control springs to avoid its free movement. Okay. We have a stop shown in the lower, and we have a stop shown at the upper of that. Right. So now under this condition, we have shown a current IA current. This IA current is actually A stand for actuating current. Right. Now under this condition, the right hand side of this armature, which is now electromagnet for us, become north, and the left hand side, of course, is south. So gentlemen, what do you think? With this polarity of the actuating current, the relay will operate or not? The relay will definitely operate, because the north pole of the polarized magnet and the north pole of this armature, this, of course, because that is fixed and it can move, that will repel this. Similar pole repel each other, so it will come downward. And on the left side of this, we have the north pole and south pole, and this north pole on this will attract the south pole. Right. So under this condition, it will move in the forward direction, and this contact will be made. Right. So now this shows the operative currents, for example, for this type of relay. Now let's say I told you that already that the polarized current remains fixed. That has not been changed. It is a fixed supply and fixed direction. Let's say, for example, the operating current direction is changed. Operating current direction is changed. That is IA, which is shown in the upward direction, is now coming to the downward direction, right? So with this previously north pole will become a south pole because the left hand side of this will become the north pole, right? So under that condition, this north pole will rather repel the previous north pole, will attract this because now it is a south pole for this, and of course it will have a downward force on this, and the relay will not operate, right? So with these type of arrangement, we have given a directional characteristic to this type of relay by using a polarized type of electromagnet or a permanent magnet. So this relay operate only when the current flow only in one particular direction. If the current flow in the reverse direction, the relay will not operate. In the previous structure, we have seen that whether the current flowing in the forward direction or in the reverse direction, the relay has to operate. But now the same electromagnetic attraction type relay, we have made this relay as, of course, directional relay update. Gentlemen, if you have any question about this, and you must have some question about this because this is you check because the conjugation gap or whatever may be can't explain on the board sense. So you just read it, see it clearly, and as many points as you can raise. When I have attraction, please raise all those points so that you make the point itself. Right? So please. Okay. Now, principle of operation or operation principle. The principle of operation is explained with the help of the above diagram, which we have seen just. A movable armature is shown as magnetized by current flowing in actuating coil and circling the armature and with such polarity as to close the contact. A reversal of polarity will cause the contact to stay open. The polarized or field coil of magnetizing the polarized magnet, or it may be a permanent magnet, as I have already mentioned this point, that it may be a permanent magnet where you have permanent north pole and permanent south pole, but the north pole and the south pole of the actuating structure, that is of course that particular armature, can be changed by the direction of the actuating or operating current. So therefore tending to move the armature may be expressed as I explain all these points to you. You just read this, and if you have any point, so please raise. Okay. Now, therefore, the net force depend upon not only the one current as in the previous case, because at that particular case we have only one current source. So the force was directly proportional to the square of the current. But here there are two currents. One is IP current, that is the current of the polarizing magnet. IP is that current which is flowing in the polarized magnet. And the other current is of course actuating current. Actuating current as well as your operating current, that's your system current. System current, it depends upon the normal load current, and in case of fault it depends upon of course the fault current. So therefore K1 is again a force conversion constant, and K2 is again of course all restraining forces in the system, including of course friction. So F is equal to K1 IP IA minus K2. So this is the basic force or torque equation. At balance point, the net force or net torque F is equal to 0. So that is naturally that balance point at that point where the operating force is equal to of course the restraining forces. So at this particular point, net force is equal to 0, and IPIA is then will be equal to K1 divided by K2. So if either IP are reverse or the forces will be reverse. Okay. Now gentlemen, since in this particular case we have seen a polarized magnetic current IP, so more or less it is constant. So IP remains constant because we have a fixed battery and we have a fixed current flowing in this. The only variable in these equation, see, either even it is written that if IP is constant, and naturally it is constant because we have a fixed polarized current magnet. So then Ia is equal to K2 divided by K1 IP. It is clear from this equation, and therefore the graph below this is shown that we have torque naturally on the x-axis, and of course the actuating current Ia on the y-axis, and we have a boundary here. This boundary of course differentiate between a positive torque region, it bisects into a positive torque region and negative torque region, and right at the boundary of this we have Ia equal to K2 divided by K1 IP, and when the current increases this value, that is K2 divided by K1 IP, then we enter into positive torque region, and below this if the current operating current is less than this value, we have a negative torque region of this. So this graph is clear. Even then, if you have any question, any other, of course, you need more explanation about this graph, you can have in particular the discussion clear yourself. Okay. Now, gentlemen, these two type of, particularly the second type of relay, this type of relay. You see the previous relay, which was a simple electromagnetic attraction type, and non-direct relay, which has only one coil. That is the first relay we have discussed today. Can be operated, as I have mentioned in that particular session, it can be operated from a single DC source or from a single AC source or even voltage sources. But this relay, which has a directional type of characteristic, and the relay we just discussed this electromagnetic directional electromagnetic relays, it can only be operated. It can only be operated, or it can only be used for DC circuit. Because in the if you are using in the AC circuit, then the polarity of the actuating magnet will change, right? So therefore, we will have just and vibrating force, and there will be no constant force to operate the relay. If you want to use this relay for any AC circuit, for the protection of any AC circuit, then of course we have used the rectified version of that. We have to rectify the AC current into DC current, and then we have to use this relay. Otherwise, direct you cannot use this relay with AC quantity. You see, with AC quantity, the polarity does not remain constant. Therefore, when the polarity remains constant, then the force of attraction, of course, will not be constant. It will be four phase sometime, changing for so many times per second. So this point is, of course, very important to note. Okay. Now, the next type of relay is induction relays, which is, of course, very popular relays for our system, uh, because these are used normally, even today, these are used electromagnetic induction relay, operate on the principle of induction motor, and are widely used for protective relay purposes involving AC quantities. So naturally, as it is clear from its name, induction. So these type of relay cannot be used for DC. They can only be used for AC quantity or for AC circuit, for AC transmission line or for AC line. So now, an induction relay essentially consists of a pivoted aluminum disc placed into alternating magnetic field of the same frequency but displaced in time and phase. The torque is produced in the disc by the interaction of one of the magnetic field with the current induced in the disc by the other. Now, you see there on the left hand side, that is figure number 1. we have shown a section of a rotor which is cut by two fluxes, phi 1 and phi 2. And naturally these are AC fluxes, so these two fluxes produces two current, right? Phi 1 produces I1 current as it is shown with the directions, and phi 2 produces I2 current. So two currents are produced in this particular portion of a rotor. But consider this is a rotor of a motor, because this basic principle is of course rotor principle. You might have studied single phase motor, so it is on the same principle. Okay. Now then on the right hand side, we have these current, since these are circulated and these are the direction force. Then of course I1 current, which is produced by the flux phi 1. Just listen to me clearly. I1 is the current produced by flux phi 1. It interact with phi 2. Current I1 interact I phi 2. Current I1 interact with flux phi 2. Because you see, the force of attraction or any force which is produced in these big data depend upon BIL. B is of course flux density, I is the current, and of course L is the length of that particular. This is a magnetic, from the magnetic circuit we can use BIL as a popular equation we have. So this produces a force, and that force is indicated as F2, right? Clearly shown F2. And another force is produced. Another force is produced by the current I2 interacting with phi 1. So phi 2 I1 interaction produces F2, and I2 phi 1 interaction produces force F1. So we have these two forces, and when you have in any system two forces always produces a torque. Single force cannot produce a torque. Single force can produce attractive force or repulsive effect or attractive effect. But it cannot produce. For the torque, at least we require two forces. And in this particular system, two forces are produced, F2, F1, and then the torque will be the difference. First of all, let's say, for example, forget about these force of attraction or torque force. Let's say, for example, phi 1 is phi 1 maximum sine omega t, and phi 2 is phi 2 maximum sine omega t plus alpha. These two fluxes must have some phase difference between them. If there is no phase difference between phi 1 and phi 2, then it will be considered as only one flux. They will show their identity as two flux because they have phase angle between them. By the time phi 1 is maximum, phi 2 will not be maximum. It will have another value depending upon the alpha value, right? Even it can be zero at that particular moment if suppose it is 90. So therefore, you cannot have two fluxes with with no phase displacement. Force displacement is must. So therefore, phi 1 is assumed to be phi 1 maximum sine omega t, and phi 2 maximum sine omega t plus alpha. This alpha is the phase difference between these two fluxes. Now naturally we see the current which is produced by phi 1 as I1, and by very famous Faraday law, the current is directly proportional to the rate of change of flux with time. So it is shown below in equation d phi 1 dt directly proportional to d over differential of dt sine phi 1 maximum sine omega t, and therefore I1 is directly proportional. I am using proportional. Therefore, you cannot just claim that y omega is not taken out of it, right? So it is because I am not using any equality. I am just using proportional. So I1 is proportional to phi 1 maximum cosine omega t. I think you must have understand this equation because I'm using not the equality sign, I'm using only the proportionality. So of course, now then I2 is directly proportional. Then I2 is directly proportional to d phi 2 dt and directly proportional to d phi 2 maximum cosine omega t plus alpha. Okay. Now, gentlemen, in the previous case, we considered two forces. One is F1, which comes from the interaction of phi 1 with I2, and one is F2, which comes from the interaction of phi 2 with I1. Therefore, see here, that is the net force F is directly equal to F2 minus F1. So that F is directly equal to phi 2 I1 minus phi 1 I2. So two forces are produced, phi 2 I1 interaction F2 and phi 1 I2 interaction F1. So the net force available to produce the torque is phi 2 I1 minus phi 1 I2. So you see, these are simple calculation for you. That is, F is equal to F2 minus F1, and F is directly proportional since we have already. So this is phi 2 sine of omega t plus alpha, and phi 1 cosine omega t, and phi 1 sine omega t, phi 2 cosine omega t plus alpha. So phi 1, phi 2 is common, and in the bracket we are left with sine omega t plus alpha cosine omega t minus sine omega t and cosine omega t plus alpha. Close. Now, gentlemen, this is summarized as phi 1 is f is directly to phi 1 phi 2, which is common, and of course this explanation is reduced to this form sine omega t plus alpha minus omega t, because if you expand you will get the equation. So force is directly to phi 1 phi 2 sine of alpha. Since phi 1 is directly proportional to I1 and phi 2 is directly proportional to I2, because these fluxes are produced by currents. Phi 1 is produced by current I1 and phi 2 is produced by current I2. So therefore the net force F is directly proportional to I1 I2 sine alpha. Now, gentlemen, these are the basic equation which is applied for all induction relays, because this is basic principle of all induction relays. Then we have, of course, different structure of the relay. That structure will be discussed in the next lectures. That we have whatever meter structures, we have, of course, so many other structures are there that will be, of course, covered in more detail, but all are using the same type of mathematical equations. So just this is the basic principle of induction motor, and as far as the detail of the structure or construction is concerned, that will be taken in the next lectures. So you just see this all this, and then I have interaction with you. So you just raise any point, any question, any ambiguity, any small or large point you can just raise and clear yourself with these. So following points may be noted from these expressions. The maximum force will be produced when the two fluxes are 90 degree out of phase if the angle between these two currents or two phases are 90 degree. Then of course maximum force will be produced, because in that particular case sine 90 is 1, so therefore maximum force is produced. Now the net force is the same at every instant. So naturally, the direction of net force and hence the direction of motion of the disc depend upon which flux is leading. The following three types of structures are commonly used for obtaining the phase difference in the fluxes and hence the operating torque and induction motor. Now, gentlemen, these are three structures: a shaded pole structures, watt hour meter or double winding structures, and induction cup structures. Apart from this first one, that is shaded pole structures, all other structures are mainly fed from two sources, either two current sources or one voltage source and one current. They can one current source. They can also be made from one source, one current source, by producing phase angle by using different circuit of different x by r ratio, right? So if you two current, you divide into two circuit, one is different x by r ratio to the other circuit, so there's always produce a phase angle between them. But the shaded pole structure is the only structure which can only be produced, which can only be operated from only one source, one current source, right? Or even you may say one voltage source. So later on, which we have to take this topic, I'll explain the function, of course, of shaded pole structure. Now, gentlemen, uh, if any structures, because we have derived this force in terms of two current sources, I1, I2. If let's say, for example, one is a current source and one is a voltage source, then of course, what will be the force, net force applied? Then of course, it will be shown to you when I have interaction with you, that when one is of course voltage source and one is a current source, then this particular relation, that is I1 I2 sine of alpha, will be slightly modified, and you will see why these are modified and how it is modified. This I will show you later on when I have an interaction with you, direct interaction with you. And the okay. Now, gentlemen, this structure uh, is of course consists of a pivoted aluminum disc free to rotate uh, in the air gap of an electromagnetic. Okay. Now this disc is basically aluminum non-magnetic material. This disc which you see in this particular, and we have shown some shaded pole. Shaded pole. Now, one is main actuating coil, that is it is fed from CT or from any other source, that is the main current which is produces the flux in this particular medium, that is in this particular structures. Now we have two small coil. This shaded pole is two small ring. Ring is just a closed circuit, or coil or ring, right? Now, therefore, on account of this actuating current, it is AC quantity, voltage is induced in this particular, and since this ring is closed ring, current is produced. So now again we have two current. One is the actuating current, and one is the current produced in this shaded ring. Shaded ring. So two current. Let's say this current is I1 and this current is I2. So now we have two current I1 and I2. Since this is induced current, so induced current has an angle with the, of course, actuating current. It's also angle between them. So now the force of attraction, or force of rotation rather, not attraction but rotation, because it's basically torque. Two forces produces the torque equation, and of course, then of course this torque is produced in this particular air gate because of these two current. One is the actuating current, and one is of course the current which is produced in the shaded ring, because these are closed rings. If these rings are to be open, there will be no force produced, no torque will be produced. So this is because of this. So this is very popular structures, and all IDMT relays are being fed on this type of structures. You can see like that. But these are slow relay, slow moving relay. These are not very fast relay. These are not very fast relay. Okay. Now, gentlemen, this watt-hour meter are double winding structures. Why it is called watt-hour meter? Because a structure is similar to energy meter or watt-hour meter, which are installed in our premises, homes, or any other premises we have. So it has two coils. One is voltage coil, and one is of course the current coil. And uh, on account of these voltage coil and current coil interaction, the necessary torque is produced, and we have not a continuous rotation of this disc as it has happened in energy meter or what, but it is slightly click on that, and when it click down, when slightly move, it make a particular let's say close a circuit. So the upper electromagnet carries two winding, the primary and the secondary. The primary winding carries the relay current, while the secondary winding is connected to the winding of the lower magnet. The primary current induces EMF, and the secondary, and so the circulating current I2 in it. The flux phi2 induced in the lower magnet by the current and the secondary winding of upper magnet will lag behind phi1 by an angle alpha. So I've told you that both type of connection can be formed. One connection is of course current connection, two current connection or one voltage connection, and of course one current connection formed. So this is basically that type of structure we have. Uh, so the next one. Okay. Now this is very important, induction cup structure. Uh, this is the, I think, the very fast relay that is in operation time less than zero point 0.1 second even. It most closely resemble an induction motor, except that the rotor iron is stationary. Uh, Only the rotor conductor portion being free to rotate. I'll show this to you when I have interaction with you, right? Pointing that particular figure, because in this particular structures uh, we have four poles. It is four pole, just like a four-pole machine. These opposite poles are combined together to one source, and the other is opposed to the other source. These two combine one source, and the other two combined with the other source. Now inside this, we have a hollow rotator, a hollow rotating part shows, and in between them we have a solid iron. This solid iron is used only to increase the permeability, because if this iron is not used, we have air, and here is not so high permeable material, so their steel is used, but this steel is stationary steel. It has no connection with this hollow, which is of course actually moving, because if this hole is steel, then of course its inertia will be very high, then it will be very difficult to do this one. So a hollow outside this is a rotating material or rotating component, and inside that we have a stationary component, which only to reduce that particular or increase the permeability of that particular uh, circuit. So naturally it is used from two current sources. Even one voltage source can be used for them, but two current sources are used. So one current source is this one, these opposite, and one current source is this one. I explain this mindfully to when I have to interaction with you. So you just see it. If you have any point, just note this point and just discuss with me in the next, of course, meeting.